Understanding security testing in ReadyAPI is best done in a hands-on manner by actually implementing a security test. However, I do think it will be useful to understand a few concepts before we dive in. First, let's discuss the objective of security testing. This helps identify vulnerabilities in your APIs before they can be exploited. It ensures that your services are protected against common threats such as SQL injection, cross-site scripting, and weak authentication. The great thing about ReadyAPI security testing is that you don't have to configure the security test yourself. These tests often need to be very, very comprehensive, and it's impossible for one person to hold all of that knowledge to actually implement these different kinds of tests. ReadyAPI includes pre-configured security scans that simulate attacks on your APIs. These scans include fuzzing, boundary testing, and testing for invalid data types in your inputs. These can be added to test cases to automatically assess how the API responds to malicious or malformed inputs. Another cool feature about security testing in ReadyAPI is that the security scans are run as a part of functional test cases, allowing you to reuse existing request configurations and assertions. The integration makes it easy to combine functional validation with security checks all in a single automated workflow. The most important thing to understand about security tests is all of the built-in scans that are available in ReadyAPI. In addition to these built-in scans, you can of course configure your own security tests as needed. Let's discuss some of the built-in scans available in ReadyAPI. The first is the boundary scan. This scan checks how your API reacts when it receives values outside the expected range, like very large numbers or overly long strings. It's very useful for uncovering crashes or unexpected behavior caused by limit violations. The boundary scan in ReadyAPI is applicable only to SOAP APIs and not to REST APIs. The cross-site scripting or XSS scan looks for places where an attacker might inject malicious JavaScript into responses. If successful, it could allow attackers to hijack user sessions or manipulate browser behavior. The fuzzing scan throws a bunch of random and unpredictable inputs at your API to see how it holds up. It's a great way to find unhandled exceptions or stability issues related to bad input. The HTTP method fuzzing scan tries using uncommon or unsupported HTTP methods like put, delete, or even made up ones. It's designed to check whether your API mistakenly processes requests that it actually shouldn't allow. In the invalid type scan, ReadyAPI sends inputs with the wrong data type, like a string where you expect a number or vice versa. The objective is to see how your API behaves when the data format isn't what is actually expected. The invalid JSON type scan specifically targets JSON inputs, and it replaces values with types that don't match the expected schema. This helps verify whether your JSON parsers correctly validate and reject malformed content. The JSON fuzzing scan is another version of the fuzzing scan that focuses on JSON based post request, injecting random junk into the payload. It tests how your service handles malformed or corrupted JSON input. The JSON boundary scan is similar to the regular boundary scan but applied to JSON payloads. It checks if your API can handle edge values for numbers and strings within structured JSON data. The sensitive file exposure scan tries to access files like .env files, backup or configuration files that may have been exposed by mistake by your API. It's useful for spotting leaks of sensitive internal information. The malicious attachment scan simulates uploading harmful or malformed files to see how your API handles them. It checks for weak points in your file validation or upload logic. The SQL injection scan injects database commands into inputs to see if your app builds unsafe queries. If the API isn't sanitizing input properly, attackers could steal or alter data. That's what the scan protects against. The weak authentication scan reviews the structure of your authentication methods to spot weak spots, like using basic auth without HTTPS. It flags insecure setups that might be easy to bypass. These security scans serve as individual test steps in your security test, and you can add special security assertions for each of these scans as well. These security assertions are meant to validate whether the API responses expose the vulnerabilities of your server. The general purpose assertions that you've seen in functional tests can be configured for security scans as well. In addition, there are special security specific assertions, such as checking for inadvertent sensitive information exposure.